welcome and thank you, Casey, for this opportunity. I really appreciate it. And to my distinguished colleagues, I thank you for your participation, and I'm very excited for our discussion today. With regards to the topic, what I would like to do is just provide a historical perspective in the offshore energy sector and provide some key points going forward. With regard to the agenda that I'm going to cover like I said, the historical background, some recent developments, and then some takeaways. When we talk about developments, we talk about energy. Some of this ties over somewhat to the onshore side of our energy history here in the U.S. I think it's very important to note these early elements as well. In 1821, in New York, actually, New York State, we had a Mr. Hart who drilled into a gas-bearing shale. You know, everybody, as we discussed today, will be very familiar with what's going on in the shale industry, shale gas specifically recently. But even as early as 1821, you had a gentleman who was very much an innovator, and he piped natural gas and burned it for illumination in New York State. Probably one of the more famous discoveries or innovations was the use of the drilling rig by Colonel Drake in northwestern Pennsylvania. There's a photo on the right of the slide that I have here that shows Colonel Drake, and this is from the Drake Well Museum. Even though it kind of looks, from our perspective, kind of rickety, given the innovation at the time, this was a substantial step forward in the energy sector. In addition, in 1901, some of you may or may not have heard of Spindletop, Texas. It's near Beaumont, Texas, to give you an idea, in East Texas, the geographical location. Innovation there, you had some innovators who used drilling mud. Those that may not be familiar with drilling mud, this is a mud that helps control the well pressure. It keeps the formation from leaking out the gases, and it helps control the well when you're drilling. This was in the annulus of the well, and this was a substantial innovation and allowed drillers to control their operations even more. And it was a result of the discovery that was found there with regard to the crude oil production. This was a substantial innovation to help launch the even earlier or later developments, I should say, in the East Texas oil field. Then we moved to the offshore environment. In 1938, offshore Louisiana, as many of you know, a lot of innovation has taken place in the offshore industry since 1938, but at least in the early stages, you had a freestanding drilling platform in the Gulf of Mexico. This was built by Brown and Root for Pure Oil and Superior Oil Company. The key thing here is this was the first steps offshore here in the U.S. Traditionally, we've been an onshore type energy, oil and gas industry, but then we started moving offshore, and this was an important step in that process. Then in 1947, we had a couple of innovations. One, Brown and Root built its first out of sight of the land, I should say, rig, and this was for Kerr-McGee. So we really started moving offshore at this point, substantial way. And at the same time, in Kansas, again, this was an onshore type situation, but we had hydraulic fracturing first used to stimulate production. And a lot of people may be familiar with fracking nowadays, but it was first used to stimulate production in Kansas in 1947. Substantial discoveries, we've talked about Spindletop. I touched on East Texas, which actually took place in the 1930s. Probably one of the more substantial oil discoveries in the U.S. history was Alaska's Prudhoe Bay in 1967. And then we have a couple of events that really aren't, well, the first one I should say is not really innovation, it was more geopolitical. In 1973, we had the Arab oil embargo, and then most recently we've had the U.S. oil and gas boom, which has been something of a surprise to many people, considering that a lot of experts were saying that we reached peak oil in the U.S. in the 1970s. Some recent developments. As many of you know, the U.S. oil and gas industry has somewhat been hindered as far as employment. One of the main reasons is because of the crude oil prices, natural gas prices over the last few years. As you can see, this chart shows, now I want to highlight, emphasize, this doesn't just include offshore oil and gas workers. This includes all U.S. oil and gas extraction employees, so both onshore and offshore. But you can see over the last 10 years, you had a substantial increase from 2006 up to 2014. And then, as no surprise, when the crude oil price began to go down in 2015, the number of employees also went down. So you can see both peaks in 2008, 9, and also 2015 corresponding with decreasing oil prices. Now, a lot of us may think that the offshore environment is very, simple. This slide here, I want to highlight some of the important aspects. You can see this is just to give you an idea of geographical reference. This is the offshore Gulf of Mexico. Let me try and highlight this. Excuse me, sorry about that. This area up here below the title is Houston. This is Galveston Bay, and over here you have the boot of Louisiana. It's important to note that just offshore the Gulf of Mexico from Houston and New Orleans is a very stable slope shelf. We call it the shelf of the Gulf of Mexico. It's very homogeneous when it comes to the surface. As you get to what we call the outer continental shelf, you can see a lot of undulations in this slide. In this particular slide, what we're showing here is the bathymetric depths, and as you move from the shelf to the outer continental shelf, there's a lot of undulations, a lot of canyons, a lot of instability. These relate to turbidite flows, a lot of mudslides, debris flows that have developed over time on the outer continental shelf. So these pose substantial challenges, not just for oil and gas, but also other developments in the offshore environment. And of course, as you move further out, you get to the abyssal depths where you see the dark blue of the slide. How do we adapt to these challenges? Well, it's important to note that not just in the oil and gas sector, but also, as we're going to hear later, when it comes to alternative energies such as wind, we have a lot of innovation when it comes to different facilities that we've developed over time. It should be no surprise that in the Gulf of Mexico we've developed some of the most, I guess you would say, innovative and important technologies in the offshore sector that we've seen anywhere in the world. If you look to the slide, the top image, we have the fixed platform. That fixed platform is very common on the shelf, very stable environment, but as we get to the outer continental shelf, we move to compliant towers, tension leg platforms. There's also in the bottom image, you can see that we have other technologies that floating production and subsea systems that we've used in the outer continental shelf, where we get really substantial depths, even at 7,000, 8,000, even 10,000 feet of water depth. We have spar technologies. We have floating production systems, and we've recently started using FPSOs, which are floating production storage offloading units. These have been traditionally used in Africa and Brazil. They're not new as far as technologies. They've been around for many years, but they're new in the sense that we've adopted them and started using them here in the Gulf of Mexico of the United States. One of the other things that is common when it comes to oil and gas and also energy production, there's a lot of things that are going on at the subsurface. A lot of people have noted that we had the incident with Macondo. There was a lot of crude oil that was leaked into the environment in the Gulf of Mexico. It's important to also note that on an ongoing basis, the U.S. offshore environment does have a lot of natural seepage that occurs over time. These seeps, this is an image that shows that. This is a multi-beam backscatter image. In other words, this is another technology that we've developed when we want to look at bathymetric surveys of the seafloor. And what this image shows is you can see the seafloor. The important thing for us to highlight in this particular slide is you see the slight or green images that are seem to emanating from the seafloor and into the column of the Gulf of Mexico, the water column of the Gulf of Mexico. These seeps occur along micro seeps, in other words, just through the formations themselves, but they also, the seepage also takes place along faults and fractures that are very common in the Gulf of Mexico due to the, as if you saw the previous slide where I was talking about the complicated structures that you see in the seabeds, there's also complicated seafloor undulations, but there's also complicated structures, faults, folds that, and also there's also a substantial amount of salt deformation that causes certain fractures to occur within the seabed, and this allows also some of the hydrocarbons to emanate not only around micropores within the formation, but along these fractures as well. As we move into additional types of energy and developing these within the offshore energy sector here in the U.S., we're using a lot of the technology that we've developed not only onshore, there's with regard to drilling mud, we've talked about that, we've talked about drilling rigs, but also some of the platforms that we utilize, some of the jackets, we are also utilizing those, as we're beginning to anyway, here in the U.S., they've been utilized around the world. In the U.S., we basically have no offshore operational wind farm. However, this is about to change. As Jim will talk about in a few minutes, we have Block Island. There's a deepwater wind project that he's going to discuss, but a lot of this information or this technology that we've developed over in the oil and gas sector is now being transformed and utilized in the wind sector as well as we move into offshore wind developments. What's next? When it comes to innovations and developments technologically, this is one of the keys. Here in the U.S., we've been very much at the forefront of technological development. In fact, Houston, Texas is one of the foremost areas when it comes to developing offshore technologies, as well as other cities and areas around the U.S. Regulatory environment, there's always issues with regard to taxes, competition, antitrust, environmental concerns, and also safety. These are always critical in how we develop our technology and utilize them in the offshore sector. And then there's also the geopolitical risk. You got to remember that we're not just isolated here. The offshore energy sector has to compete with energy sectors around the world. As we know, crude is a commodity. Natural gas generally has been transported via pipelines, but as we've seen in the last 20 years, natural gas is now almost becoming a commodity in the LNG sector. It's not quite there yet, but we anticipate in the near term. So what we're talking about, developing offshore wind, solar, other technologies, we have to consider the geopolitical environment that we live in, and that developing these technologies and using the fuel as we go forward is not one in which the U.S. can do that in isolation. We have to take into consideration what the rest of the world is doing. I would say going forward, as we've seen over the last couple hundred years here in the U.S., energy will continue to develop, but the key will be not just in our own backyards, but also fostering innovative approaches throughout the world and adopting those here in the U.S. Thank you.